Good morning, colleagues. Good morning, learners. My name is Tabang Ntie, Subject Advisor for Fiscal Sciences, based in Thabo Mofutsanyane, specifically in Qwaqwa. Today we are going to do a memo discussion for the Fiscal Sciences Grade 12 test that was written yesterday. We are going to share the presentation with Memo, who will join us later. So I'm going to do the paper 1, and she is gonna do paper 2. So we will do both the sections together. And then before I can even start, let me thank you very much, colleagues, for the contribution that we are doing towards the improvement of the subject and also for the improvement of our results in general. I think I'm talking here on behalf of all our subject advisors and also the leadership of Major Netanel and Tate Velman. So colleagues, in today's paper, which was written yesterday, the memo discussion, it gives me also a great pleasure to can have received the contributions from other teachers, which we are going to put in maybe on the cloud space as other options which are not in the memo. And we also encourage you to do the same every time we have written a test, and every time maybe you are having a question, just put an SMS or any other way in which we can communicate. Now, for the paper that was written yesterday, we did not receive any of the other options for paper for question 1. So we are going to accept all the answers in question 1 as they are. But before I even go, I want us to look at the first page. Basically, with 1.1 as a multiple choice question, we will know what it is in the diagnostic report. Remember last year, in November, there was a problem with the normal, the reaction to the normal, where learners just put it as a weight, as a action-reaction pair with the weight. So because of that, then we say, in order to maybe put across for the teaching purpose, that we now include another question based on that part of the normal. But in this case, we did it not, because if you look at the question the way it is actually telling us we have to go and look at the objects. So it is important that the learners get the correct options for their objects. And question number 3, it is emphasizing quite a number of things. One, the figure itself, it is one of those parts where the way the forces were drawn, it was actually telling us to look at how the normal it is drawn in the force diagram. So there was a movement from the free body diagram to a force diagram, and also the weight and the friction. It is unlike maybe with the friction, the force is a bit up, but actually it should be with the surface. But because we couldn't just put an arrow there, then that is why maybe that arrow it is just above. But in essence, this is what we want to look at, and then maybe emphasize quite a number of things about the paper itself. Now, based on that other question, then it is very important also to can have a look at the different scenarios where we are using a normal. So this question, it is good question, especially for the grade 11s. And now that these learners were doing grade 11 last year, but we are not so sure about the learning losses, then that is why these questions were put the way they were in trying to address the learning losses for this particular topic on Newton's laws. So basically, this is how the paper it was structured, and then the thinking behind the paper, it was addressing the learning losses and also trying to reinforce our teaching in the subject. Now for the answers we are going to accept as they are for question 1. So we haven't received any. So each question will be for 2 marks, and then you are having those answers as they are, and then nothing has changed for those questions there. So for question 1, we are going to accept the questions as they are, and then we'll be looking at other parts of the paper, and then we'll go further than that. Now let's move to question number 2. Question number 2, it is based on Newton's laws. Now if you look at that question on Newton's laws, then it is like this. A block, mass M, is resting on a rough horizontal table, is connected by a light inextensible string, passing over a light frictionless pulley to another block with a mass of 260 grams. The 260 grams hangs vertically as shown in the diagram below. Now, in this case, also, it was a matter of learners maybe not just read, but it was about the conversion. So it is very important that the mass must be converted to kilograms, because with paper 1 we are working with kilograms, meters and seconds. Those are the basic units that we are working on. So it was testing that skill also as to whether they do follow. And then a force of 60 newtons is applied to a stationary block on the table at an angle of 10 degrees to the horizontal. It causes this block to accelerate at 2.89 meters per second to the left. Now, the coefficient of kinetic friction between the block and the surface of the table is 0.3. Ignore the effects of air friction. The first question is define the term normal. Now, the normal, then we are marking it like we are marking in December. So that for any one of the underlined keywords or phrase in the correct context is omitted, then we deduct 1 mark. Now, in this case, what we want, it is that the perpendicular force or component of the force exerted by the surface on an object in contact with. Now, the key words there, it should be a force which is perpendicular, and then it is extended by the surface. So everything there, it is, if everything it is there, then the learners will get 2 out of 2. So it is important also to can have a look that here there is a chance that if maybe one of the keywords it is missing, then the learners can still get 1. So it doesn't necessarily mean if any of the weights one by one, if maybe two weights are missing but the context is there, then that learner is going to lose 2 marks. No, it is that he is going to lose 1 mark. He or she will lose only 1 mark. So I think it is clear with that one there. The second question, which is going to be question number 2, and then it says they calculate the tension in the string. Now for the tension in the string, it means then we have to concentrate on the block that is having enough information to can calculate that tension. Now, between the 2 blocks, then it means the one that we are having a lot of information or enough information that we can use to can calculate that it is going to be the hanging block. It is the one that we are going to use. Even though in this question, we didn't ask the free body diagram, it is advisable that whenever you are calculating this or approaching this topic or maybe this scenario, it is important that we draw the free body diagram for both blocks separately. So it means therefore that because we are going to concentrate on that one block which is hanging, now the forces that are acting there, it is going to be your tension and then it is going to be your weight. No, the question didn't ask for the free body diagram, but in the memo here which I'm using the free body diagram to can answer the question. Now basically it is because this is accelerating. They told you that it is the blocks, the system is accelerating to the left, but it is the M block that is going to accelerate to the left, but the one hanging, then it means it is going to go up. So in this case the tension, it is going up and then the weight, it is going down. It tells us that now the acceleration for this, it is going to be a positive one because we have given the tension a positive value here, as you can see here. So from there, it means we are applying Newton's second law. So if we apply Newton's second law, then we are saying for any of those formulae can be F net equal into MA, or T minus the gravitational force, then will be equal into MA. 1 mark for that formula, and then the other mark, it is on the substitution. So when they are substituting, then ultimately, in this case, then it is going to give you an answer of 3.299 newtons. Now remember, if there are no units there, then that the learners must forfeit that mark for the unit, and then you indicate that they have lost that mark for there, so that when we do moderation, then at least we can see that there was a mark missing there because of the missing unit. So that is one way of marking and making it this way. Now, the second question is in 2.2.2. It is calculate the mass M. Now, for calculation of mass M, it means we have to go to this block, which is going to be the block on the horizontal, lying on the horizontal. Now, if it is not lying because it is accelerating, now what is going to happen in that particular case, still in that point, then we still have to draw what? To do the free body diagram and then try to work with ever force that we are having. So in this case, I tried to draw the free body diagram for that. Now we are having the normal force, we are having the horizontal force. Now remember, this horizontal force, it is the component of the force that was applied. So it was pulled at that angle. So that means that horizontal force of the applied force, it is going to be the one that is causing this object to accelerate to the left. And then we are having the normal, and then we are having the F perpendicular. So the F perpendicular and the horizontal are the ones that are responsible for that force there. So we have resolved that force, which is grade 11 work. And then there is a tension, and then there is also a friction. And then along the y-axis also there is a weight. So we are going to use everything which is in that. So you can see maybe these forces are going to play a very important role. Then it is going to be easier if the learners have drawn the free body diagram, even though it was not asked. Now for this case, how do you allocate marks? Now we are saying that it is going to be positive marking from 2.2.1. Now in 2.2.1, we calculate the tension. So meaning that whatever value that these learners have for tension, then he's taking it as it is and then he's putting it into this substitution step here. And then for doing that, it is immaterial how much it is. It can be different from that one, but you as a teacher, what you do, now for that value, you are still going to award a mark, and then it means we have to redo the calculation there. So maybe your answer will be different from what we are having, but in this case, we have taken that value that we have calculated there, and then we substitute it here, and then that's why our answer, maybe it will be looking like this. Now let's look at this, what is happening here. Now it means we are going to look at all the forces there that are causing the motion. It is going to be a horizontal force, the component, and then the tension and the friction. So those three are the ones that are causing, and then this body is accelerating, and then we have given the acceleration. So 1 mark for the substitution of M and the acceleration. 1 mark, it is actually for the calculation of the force there, which is friction. Now remember, for the friction, we are using friction, it is equaling to mu, which is the kinetic friction, which is that 0.3. But for the mass then, for the normal, now the normal, we can see from this figure that the normal actually, it is going to be equaling to the gravitational force, and then we are going to subtract the perpendicular component from there. Hence here, this M multiplied by G is going to be a gravitational, and then your component, which is vertical, it is going to be the amount of that force and then the sine of 10. So for that whole substitution there, it is 1 mark. And then 1 mark, it is coming from the value of the tension that was calculated above, and then the horizontal component, it is going to be 60 multiplied by cosine of 10 degrees. 1 mark for that component, 1 mark for the tension force, 1 mark for the frictional force, and then 1 mark for the part of acceleration. No mark it is given for the formula. So the total mass calculated of 10.11 kilograms with units, then it is 1 mark. So the total for that question becomes 5. Now, that is when we are looking at the motion being positive as it is going to the left. But the learners can still take it to be going to the left and then give it a positive. Now, if that be the case, that means everything that it is going to go to the left, it is going to be, according to this, it is going to be negative. So meaning that the force that is going to the left, it is the horizontal force. So that horizontal force, then it is going to be a negative force here. But the friction and the tension then are going to be positive. And then when we substitute, it is still going to be the same as in the above. It is going to be your mu. And then the calculation of the normal there, which is going to be mg minus the component vertical. Then we are going to take the tension as positive. So these two values are now positive. And then your force horizontal, it is going to be negative. And then it is going to the left. The whole system is going to the left. Now your acceleration also then now needs to be negative, because it is application of Newton's second law. So the body will accelerate in the direction of the net force. So meaning that the acceleration there, it is going to be negative because of this force being bigger than the rest when we add them. So ultimately, we still got the same mark, the same mass, which is going to be 10.11 kilograms. So for that question number 2, it is going to be 10 marks. I hope it is clear for everybody, and then there are no questions about it or qualms about it. Now, that is 10 marks for that question. Now let's go to the next question, which is going to be question number 3. Question number 3, it is a question about momentum. And then it is still collision, but in this case, it is taken as from the point of the graph interpretation. Now, if you look at why we are taking the graph interpretation, it is because this it is in the diagnostic report that the graph, it is a problem. So we are trying to help the learners with the interpretation of the graphs by giving them enough practice on different types of graph so that it is come the end of the year, then they can answer the questions. Now, let's look at the question itself. Now, it says that a ball P with a mass M is initially rolling eastwards when it collides with an identical ball Q, which is rolling westwards at 15 meters per second. Ignore the rotation effects of the balls and the friction. Meaning that immediately then the learners must understand that immediately we are taking out any external force, then we are talking of a closed system or an isolated system. So we are trying to isolate everything. So the graph below shows how the velocity of ball P changes with time. Now, in this particular case, at time equaling to 0, that is going to be the initial. So that means it is going to be 10 because they can read the velocity there. Because the time it is 0, now the velocity it is going to be at 10 there. So it is 10, and then in which direction it is rolling? Then it is rolling initially, it is rolling what? Eastwards. So that is very important now. That the positive value taken here, it is taken as east. So meaning that the direction it is given indirectly in this particular case. And then thereafter what happens? Then it collides. And then when it collides, there is a collision, and then the collision is heading for a particular time, and then thereafter there is a change in velocity now. Now look at this. Now the value of this velocity is now in the negative. Now because it is in the negative, that means that then there is a change in direction. Now it's no more moving eastwards, now it is moving westwards. Now the learners, they should have seen that, and then they should be able to can calculate that. Now the graph, now it is given to them, and then now they have to do the calculation. Now the first question, it says there, define the term impulse in weights. Now the answer that we are expecting, we are still applying the same thing. If any of the weights, one underlined keyword or a phrase in correct context is omitted, then we deduct 1 mark. So it is the norm now that this is the approach that it is being taken from national, and then we have to adopt it. Now it says there it should be the product of the resultant on the net force acting on an object and the time. So everything there it is underlined. So for the last part, even if maybe something is missing, you don't have to penalize the learners. So that means then the resultant force acts on an object. That part, it can be, the learners can still not write it, then they still have to get there. There are 2 marks. So the important thing, it is a product, and then there must be a resultant force, and then there must be a time there. Okay, so those are the keywords which are there, and then the learner will get a 2 marks. So I hope it is clear, and then it is right. Right, now we go to the next one. In the next question, it says there, calculate the velocity of ball B after collision. Now, how was ball B initially? Ball Q. Initially, ball Q, it was going westwards with 15. And then ball P was going with 10, but it was going east. So we are having those. Now, what is it that we have to do? Now, they told us that it is going to be, we have to ignore the effects of friction. So immediately, it means then, therefore, the question is based on the conservation of momentum, principle of conservation of momentum. And then for that, now we have to do that principle now. We are saying that we take motion to the east as positive, as a first option. Now we are saying that momentum before then must be equal to the sum of momentum after. It can be in that form, or the learners, they show that they are adding the momenta of each and every object or ball which is there. So it is going to be the mass of P, initial velocity of P, plus mass of Q, initial velocity of Q, then must be equal to the mass of P, and then we multiply by the velocity of P final, plus mass of Q multiplied by the velocity of Q final. So for any of the formulas there, it is going to be 1. Now we substitute mass. We don't know, it is going to be M because they didn't give us the mass. And then for the mass of P, it is going to go to positive because we said anything going east be positive from this point here. So that means anything going west, as Q was going west, then it is going to be negative. So 1 mark for the whole of that substitution there. And then it is equaling to, in the left-hand side, then it is going to be the mass. And then the ball, Q, initially it was moving westwards, hence it is negative. And then this one, it is negative. As you can see there from the graph, that there was a change in the direction, moving from positive 10 from the graph, and then we are going to negative 6. So because of that, then it is negative, meaning westwards there. And then plus, then the momentum of Q final. Then from there we calculate the velocity. Now if you calculate the velocity, it is giving us a positive value here. And then I emphasize the positive because I want to show that then we have to be consistent with when it is negative. So it is positive here. Now the learners need to address that positive. What does that positive mean? Now the positive means the one, it is going to be there as a value, and then the units, it is going to be meters per second, and then this, it is going to east, because we are saying that for any positive, then it is going to be east according to this. Now, for option number 2, we are saying we take the motion to the east as negative. So meaning that it is still the same principle, no problem with the equation. And then from there, what is going to happen now? The east here, it is taken as negative. So initially, ball P, it was moving east, so its velocity then needs to be negative 10. And that of Q, which was going west, then ought to be a positive 10. And then after collision, that means now ball P, it is moving westwards. Now it is going to be positive because it is in the same direction as the initial direction of ball Q. And then we calculate the velocity final of Q. Now the velocity final of Q give us a negative. Now what does this negative mean? Now we go to where we have chosen the direction. We said if ever we are getting anything being negative, then we must know that we are going east. So that is why here it is going to be east, and then the total for this question also, it is going to be 5 marks. I hope it is okay with everybody. No qualms about it. Now for the if you look at the final answer, there is an answer, 1 mark for the answer, and then 1 mark for the direction there, for the interpretation. So it is 5 marks. Hope we are going to get that 5 for our learners. Now let's go to question 3.3. In 3.3, what does it say? It is observed that the kinetic energy of the system decreases by 28.8 joules. So that decrease, that means initially there was this amount of kinetic energy. Now after collision, then it is this. Now basically, this is a transformation from the elasticity, where we have to calculate as to whether the collision was elastic or inelastic. So in this case, it is exactly that, but it was put in another way. So we have to calculate what? The mass in this particular case. Now, how do you use that equation? Now, what is it that we have to use? We have to use this, that what we have is the initial kinetic energy, the sum of it, it is still there, then it will be equaling to the sum after collision plus the energy loss. Or we put it that the kinetic energy, it is going to be half mp squared, half mv, half of m, v it is squared, and then the v for q, it is also squared, but that is initial. And then it will be equaling to half mass pv final of p, and then v final squared of q plus the 28, because it is lost. And then from there, what we do, we are saying now the mass, it is unknown, so we are not going to cancel the mass on both sides, because this is what we know, what we want to calculate. Now we have to do the simple calculation. So the 10 is squared, we are taking m as a common factor, 10 it is squared plus 15 it is squared. Now it is very important also to can note that because we are dealing with energy, it is not a vector quantity, it is a scalar quantity. So that 15 ought to be positive and not negative, even though it is going west, because it is a scalar, the direction is either positive or negative. So with energy, no direction whatsoever. Then it is going to be equal to 15. And then after collision, the west part of the P, it is still 1, and then that one is still also the east of it, it is still 1. So meaning that the direction here, it is not important, and then the 1. Now for substitution of the kinetic energy before, plus the kinetic energy after, plus the energy loss, we give it each of those a 1 mark. as you can see from here. We give each of those steps 1 mark, and then the final answer, we also give it a 1 mark, which is going to be 0.2, and then that 0.2, it should be in kilograms. If it is in grams or any other unit, then it is going to be wrong. So it is going to be 5 marks for that question there. So 1 mark for the formula in whatever way, 1 mark for calculating the sum of the kinetic energy before, 1 mark for calculating the kinetic energy after, 1 mark for the energy lost which is given, and then 1 mark for the mass that was calculated. The total for that question, it is going to be 5 marks. Right. Question 3.3. What about it? It says the question in 3.2, now we have to calculate the magnitude of the net force acting on the ball during the collision there, during the collision. Now, in this particular case, we have to calculate on which ball it is on P. Now, because it is on P, what is it that is going to happen? Now, there are 2 options that we can use that P is going to experience a force. Now, we say that if we look at this, now we have to apply the impulse momentum theorem. Now, F net there, it is going to be equal to the rate of change of momentum. And I want us to look at this question and then look at the multiple choice question. What is it that we have done about this? So it is an emphasis of not giving the definition only, but also the understanding of what the definition is. Now it is 1 mark for that formula, and then the extension of that, it means it is going to be mass V final minus mv initial. Now taking m as a common factor, then we still have that change in momentum, and then must have t final minus t initial. Now what is going to be the mass? Now it is going to be positive marking from 3.1 because it is in 3.3.1 where we calculated that mass. No, whatever value that this learner's got here, then they substitute it here, it is fine. So give the learners that mark for any value, even though it is different from this one. Okay, but it is important that it should be that value there that it has been put into this calculation here. And then what is the final velocity of that one? For P, the final velocity, it was minus 6. Then it is going to be minus into positive 10 because initially it was positive 10. Now we'll make that 10 to be negative. So for the top part of that equation, then 1 mark for that. Now for the time interval, it is going to be the final time minus the initial when that collision was occurring. Now we can see it is going to be from here up to that part there. So the scaling here, it is very important that these learners, they should be able to can read what it is there, that it is on the scale. Now it is at that point there. So if you look at this part, it is going to be one part, it is divided into 4 parts, so meaning that each one it is going to be 0.25. So they have to read that it is going to be 1.25 when the collision occurred, and then when it ends, it was at 1.75. So they have to read this graph. That's why I said this question, it was actually based on the interpretation of the question. So the learners need to read that. So that is why finally it was at 1.75 as the value, and then we minus 1.25. So 1 mark for that interpretation, and then from there we get a negative value. So that negative value, what does it mean? Then they have to interpret it, but unfortunately we didn't ask for the force, we asked for the magnitude. So then it must be a positive value of 6.4 newtons, and then 1 mark for that. Okay, then the other option, it is we can accept when using the Q. Why are we accepting for using Q? It is because this is the application also of what? Of Newton's third law. So if ball P it is experiencing a force, then the same force will be experienced by ball P but in opposite direction. Hence we are having this, that it is still the same principle that we are applying, but now we are looking at a different ball. Now which ball it is? Now the balls were identical, and then finally what we did from question 3.2, we have seen that the velocity of Q, it was equaling to 1, and then initially it was moving westwards with 15. Okay, so because of that, then we put everything as minus into minus, then make it positive, and then the time is not changing. So there will be a 1 mark for the substitution of the velocities, and then 1 mark for the times. Now there is a mistake here. It is positive 6.4, not 64, And then here we have rectified it that it should be 6,4. And then the final answer, then it is going to be only the magnitude, then it is going to be 6,4 newtons. But remember that it is not that we are just dropping the positive and the negative and we're not interpreting this, because the question asks for it do ask for the magnitude, hence then we are just giving it an absolute value for the answer, which is going to be positive. Now it is going to be 4 marks for that question, 3.3.2. Right, now let's go to question 3.4. With 3.4 now, it says that consider the initial momentum and the final momentum and change in momentum of ball P. Now we are having 3 momenta there. It is the initial, it is the final, and the change in momentum for ball P. So what is it that they are asking for us? Then we have to consider them. Which one of these vectors represent the resultant vector? Okay, for 1 mark. Now, if we remember, this is one bullet that when we go for moderation, it is done in the first week. I think it is bullet number 3 in the Free State Assessment Guideline. And then more often than not, because this question is not asked, then we tend to ignore this bullet, and it is one of the bullets that we need to do. So we are trying to enforce that each and every bullet must be assessed. So we do assess it now. Now what is it that we are having here? Now we'll see that according to what we have, then the momentum for all this, it is going to be this way, that the final, I'll explain it why we are saying that actually, that the final momentum, it is the one that it is representing the resultant. Okay, then I'll come back to this to explain, because it is for teaching. Now, how are the vectors? We are taking that initially momentum of P, it was going east. That was the initial momentum of P, it was going east. And then the momentum after, because there was a collision, now it is going west. Now for the representation of those two, then it is okay, that it is just the direction, and then the 10, it is greater than the 6. Hence this line, it is a bit longer than that one there. But now going for that answer, remember the answer, it is based. Now we are having the initial and the final. Now we have to look at the change in momentum. Now for the change in momentum, it is vectors here that we are dealing with. So basically, what we are saying is we are having a situation where we are saying change in P, it is actually equal to P final minus P initial. That is how we do it. Now, what does this mean? Because these are vectors, it is the same as saying to us that it is going to be momentum final plus the minus of P initial. Now, based on this, what does it tell you? It tells you that we have to add the vectors. Because we are adding the vectors, when we add vectors, it doesn't matter which vector quantity are you looking at, then basically we are going to get a resultant. Hence we are saying for this answer here that the final momentum, it is going to be the one representing the resultant. And then it is for that matter that we didn't allocate a mark there, because the mark, it is allocated already there. Okay, so that is that 1 mark. And then the representation of this, it is like that. But now, look at the direction. When it is like this, it is not very clear for the learners that it is the same as what we are having. Now, let's check what is it that is happening here. It means what we are saying initially, this, it was going west. Now, because of this negative, it means we are still having that one, but we have to change the direction of it because it is now negative. Now, how are we going to change this? Now, in which direction does it go now? It is going to go to the direction of the final, because they are now going to have the same. So finally, this object, it was going in the western direction, because initially it was going east. So it is final. Now we are taking this and then we are adding the negative of it, so that means it is going in that direction. So the minus of pi, it is going to go in that direction. Now we are starting here because it's an initial, and then we go in that direction for the result. And now we can see that now that is the reason why our delta p, it is going to go in that direction. Hence on the memo we reflect it that way, that it is going into that direction. So it is very important that we also try to explain to the learners how this it is going to change, where we are having both of them the same. One of them it is negative, and then what is it that we are going to get for the marks, whatever mark it is going to be there, then we need to maybe put that correctly for our learners, for them to understand. So the total for that question then, it is going to be 19 for the momentum part. So it is going to be 19. And then I think from there we'll go to question number 4, which is going to be a question on vertical projectile. So 19 marks for question number 3. Let's go to question number 4, which happens to be the last question under physics part. And then in question number 4, it's a very interesting question. I should say it is involving quite a number of things, and then thanks for the thinking behind this question. A crane at a building site is lifting a pile of bricks on a wooden pallet at a constant speed. Emphasis, constant speed. When the pallet it is at a height of 17.2 meters above the ground, one of the bricks falls off and hits the ground after 2.7 seconds. Now, here it is a graph given for that. Now, the graph, the way it is giving us the trajectory of this ball, of this brick. So basically this is showing us the position time graph. So hence it is position, the position where at which instant where was the brick, and then ultimately there it is the ground after 2.7. Now on the picture we can see that it is not starting from the ground, then it is starting from the brick is falling at when the crate it was 17.2 meters. Okay, now let's look at the first question. The first question says, why does the falling brick go up before it goes down? Right? Now, the reasons given for this, it is because of the following. One, the crate it was moving, and then according to Newton's first law, then it means it is going to be the inertia that it is going to be responsible for that. That is application of Newton's first law, because it is moving at a constant speed. So basically, then 1 mark for the inertia. But we also accept that it has a upward velocity, or it has an upward momentum. Remember, it's a brick, it is having an upward velocity. Now the velocity multiplied by the mass, then it is going to give you momentum, and then it is still going to go in the direction of the velocity. Hence we accept any of the 3. So any one of the 3 will give the learners a 1 mark. So I hope it is fine for everybody. 1 mark for that. Now let's go to the next question. The next question says, now define the term free fall. The term free fall. Now for that one, it is a term that is a question becoming more popular. Now we are saying that it is going to be the motion under the influence of gravitational force only. Now if you look at this question, it doesn't say for any of the keywords omitted in correct context or anything like that. So basically what does it mean? Because we are having only 2 marks at the end of this, now it means for this question it is either going to be a 2 out of 2 or it is going to be a 0 out of 2. So colleagues, let's stick to that. According to the memo, there is either a 2 out of 2 or a 0 out of 2. No way that this can be a question where we are having 1 out of 2. So it is either 2 out of 2 or it is going to be 0 out of 2. I hope it is okay with everybody. Okay. Now the second question, the next question, it says there, how long does it take the brick to reach the maximum height for 1 mark? Now, if you are looking at this trajectory here, it is starting from time equaling to 0, and then it reaches that maximum height at that point there. So that means the learners just need to read the time that is given here. So the time for that answer, then we are saying that that answer, it should be equal to 0.7 seconds. So the answer to that, it should be 0.7 seconds for 1 mark. So that is how it is. Hope it is clear for everybody, and then we are happy about it. Now let's look at question number 4. Number 4 says, calculate the velocity with which, 4.1, the pile of bricks were lifted by the crane. Right? Now, the crane is going up, and we know that according to Newton's first law, because the guide, it is about that constant velocity there, that the speed at which the crane, it was moving, it is going to be the same speed at which these bricks are going to be going up with it, this pile of bricks. It is going. So even that one falling, it is going to have the same velocity or the same speed as the pile. So what is it that is telling us? Now, even though the question asks for the velocity at which the brick were lifted by the crane, then it means we have to concentrate on the brick that will do it. And then we are given the graph of the brick. Now we have to calculate it. Now, for option number 1 that we are having here, we are saying V final, that means it is going to be the V at the maximum height plus V initial plus G delta T. It is going to be the formula that we are going to use, so it is going to be 1 mark. At final, at the highest point, then your V final, it is going to be equal to 0. And then V initial is what we want. And then we are saying we are taking up as positive. So meaning that this value, when we calculate it later, it should be giving you a positive value. If it is negative, that means there is a problem of a sign because you have chosen it there. But that means we are not going to look at that value. We are just looking at what the learners have done. Then we'll give them the marks. So when we calculate it, after we have make a calculation, then we can see that actually, then the value is going to be equal to 6.86 meters per second, and then it is going to go upwards. So that is going to be what we are having. It is going to be upwards. And then 1 mark for the formula, 1 mark for the substitution of V final there. And then 1 mark for this the right-hand side, where we are calculating G delta T. So that part there, it is going to be a value, and then we are taking upward. If upward it is not there, the learners need to forfeit that mark because the question asks for the velocity, not the magnitude this time. Now they have to include the direction because it's a vector quantity. Option number 2, we are saying anything going down, any of the physical quantities here going down, then it is going to be positive. Now what is it? We use the same formula. V final will be equal to V initial plus G delta T. And then doing that, we are having finally it is equal to 0. And then initially we don't know, but it is now going up. So we expect the final value to be what? Because here it is down positives. Now this value initial, because it's going up, we expect it to be negative. So if learners don't get it negative, they must go back and try to look at the sign where they made a mistake. So 1 mark for the substitution on the left-hand side, and 1 mark on the substitution on the right-hand side. So the final answer, it is negative. Now they have to interpret that negative. Now what does it mean? Then the value is going to be 6.86 meters per second. Now it is negative, but we said up it is going to be, down is positive. So meaning that if it is negative, then it means it is going upwards there. So that is how we come to the answer. So the total for that question, then it is going to be 4 marks. Right. And the other option which came to us, and then thanks for the colleague who sent it up, it is that we have given the distance here. We can see we are having distance here. So also they want us only to calculate the initial velocity there. But we know final velocity, and then we know the distance. So it is not only about the time, even though it is a position time graph. Then we can still use this. We can still use this one here. That V final will be equal to V initial squared plus 2G delta Y. Now finally, it is the same as when we are using time. It is equal to 0. V initial we don't know. And then plus 2 into negative, because we said anything going up, it is positive. Now your G becomes negative. Now here we are having this part here, that it is a change in displacement or change in position here. So what does it mean? It means we still have change in Y. Actually, it is equal to Y final minus Y initial. No, finally it is at 19,6, as you can see from the graph there. It is finally at 19,6 as it reaches the maximum height. But initially it was at 17.2. Hence here, that part here, it's very important that even though maybe the learners didn't show it as 2,4, as 19,6 minus 2, then they can still show us that it is 2,4. So it is important that for that value also we are going to give a mark, because there is a mark on that one there, and then there is a mark on that one to be consistent with the first option. And then thereafter, here when we come here, then we have to take which square root, because we are saying upward it is positive and this is going up. Now we are going to take the square root of a positive number here. And then for that matter, then it is going to be 1 mark for that part there. Okay, now if you go for down being positive, let's check down, it is positive. Now it is the same formula, no problem with that. V initial is what we don't know, and then we are having 2. Now G, it is going down, right? But now the object itself, in which direction it is going, even though it is final minus initial, now we are saying that now that means it is still going up, right? But now up it is going to be what? It is going to be negative here. It is going to be negative because we are saying there that that positive, it is when it was going down. So our object, it is going to go upward, and then now that value needs to be positive, be negative, and then when we multiply we end up with this value here of 49,4. Now when we come here, now we are taking this that side, and then what is it that we are saying? We are saying here when we take the square roots, now that square root, it can either be positive or negative. Now which one of the two are we taking? Now we are saying V initial here, it is going to be a negative 6,86. And then from there we interpret that negative to say that that negative then it is going to be 6,86 meters per second. And then it is going to go upward because we are taking the negative as a going up, because we said positive being what? Being the one that is going downwards there. So this is another option which was not in the memo originally, but it is also applicable and then it is correct. Thanks very much for the colleague who sent it, and then we accept it, and then we are very appreciative of what you have done for us. Okay. And then point 2, let's go to point 2, which is question 4.4.2. Question 4.4.2, it says there we have to calculate the velocity with which the falling brick hits the ground. So the initial one, it was when it was going up, and then now hitting the ground. So in that particular case, there are quite a number of options which we are going to go maybe step by step and then try to understand what it is that it is going. And then for that one, let's check what is it that we have done here. We try to separate the motion. Now, the first option, it is when we are looking at the whole motion, right? Now, if we look at the whole motion, it means from the instant it was starting, the brick starts to fall until it reaches the ground. So that is going to be the very first one that we are looking at for the whole motion. Okay. Now, for the whole motion, what is it that we are now having? Now, there is also a positive marking from what? From 4.4.1. And remember, in 4.4.1, we are calculating the initial velocity. So that means we are going to substitute that value for the initial velocity in whatever way in which we are going to do here. Right now, let's look at it here. For the whole motion, Now, what is it that we are having? The first equation that is going to be applicable, because we want the final velocity, the velocity with which it hits the ground. Now, here we are saying the formula that we can use is going to be V final will be equal to V initial plus G delta T. 1 mark for that formula. Right? Now we set downward, it is positive. So meaning that the initial velocity it was going up, so it is going to be negative here. And then for that negative, which you take from 4.4.1, 1 mark for that substitution there. Plus, now your G here, it is going down. So it is going to be positive, and then the total time for the motion, it is equal to 2.7. So then it gives us a positive value of 19.6. Now this positive value, it is in line with what direction we have chosen. Now it means then therefore that it is going to be the value of 19.6 meters per second, and then it is going down. For that one, it is going to be 1, 2, 3, 4 marks for that one, if the learner chooses that direction. Or for option, if the learner chooses the negative as going down for the negative, we apply the same formula. Now, what does it tell you? Downwards, it is now negative. So anything going up, it is going to be positive. So the initial velocity, it was going up. So it is going to be positive 6.86 plus into minus 9.8, which is our G going down. And then we multiply by the 2.7, which is the total time taken. Now, that means for that part there, it means ultimately when we do the calculation, we end up with a negative 19.6. Now let's interpret that negative. Now what does that negative means? It means it is going to be 19.6 meters per second, and then it is going in the negative direction. Now our negative was down, so that means now this velocity is downwards there. So that these two are the same. It is just a matter of changing the direction there. I hope it is okay there. Okay. Now let's look at the next option. We are still going to calculate the V. Now if we are looking at V, what is it that we are having here? The velocity with which it hits the ground, right? Now if you look at this trajectory of the ball, that means we are taking it not really as a whole motion, but we are taking it as a whole motion. But instead of using the time, we are now using the displacement, right? Or the position. Now let's look at it. We are saying downwards is negative. That is option number 2. Now which formula are we using? We are using V final squared equal to V initial squared plus 2G delta Y. Now initially it was going up. Now we said up it is positive because we said down it is negative. So it is going to be 6.86 squared. As positive, plus 2, and then G, it is going to be negative. Now this object, where does it go? Initially it was going up for the earth, but now the change in position, that means it is going to go down finally. So that's why this negative value here. And then from there it gives us this value here. Now that value, what is it that we have to do now? We have to take the square root. Now the square root of that, what does it mean? Now we are taking either the positive or the negative. Now for this instance, we have to take the negative value because the negative, it is the one that it is going down. Now the final here, it was going down as a displacement because this initially it was going up, it is positive. Now this one, finally it is going down. And then ultimately we are ending up with this value of 19.6 meters per second, and then it is going down because of that negative, and then the negative there. Okay. Now, or alternatively, can take down as positive. It is the same option as this one. Now, what is it that we are having? Now, for that one, initial velocity, it is going to be negative, and then we square it, plus G, it is going to be positive. Now, the displacement, as it is going down, then it is also positive. Now, here, we do the same. We take the negative square root, which is going to be minus 19.6, and then the value it is going to be 19.6 meters per second, and then we interpret the negative to be equal into to be going down. So this is how we come to that one. And then option number 3. In option number 3 for the whole motion, what is it that we are looking at? We are saying for that option, we can use the formula delta Y. It is equal to V final plus V initial. Very important about this formula, colleagues. Check that if these letters choose this, that the sign in between there, it is actually a positive and not a negative. Plus delta T. Okay. Now, what is it that it is going to happen now? We are saying now down it is negative. What is the change in position? The change in position then, it is going to be the y initial minus the y final. So it is for the whole motion. Now we are at 0 initially, and then we end up being going down negative on the negative side. So it is going to be negative 17,2. And then V final is what we want. V initial it is given. Now it is going up as positive. Now it is going to be positive. And then that's 2,7 as a time. And then we end up with this velocity. 1 mark for the formula. 1 mark for that change in displacement. And then 1 mark for the whole of that substitution in the side. And then from there we end up with a negative value, and then we interpret that negative 19,6 as equaling to 19,6 meters per second, and then it is going down. And then if the learner chooses down as positive, what is happening? We are having delta y. It is equaling to V final plus V initial all over 2 multiplied by delta t. Now what is it that is happening now? The delta y, it is still going down, but we are saying down be positive. Now hence this value is going to be positive. And then the final velocity we don't know, but the initial velocity there, it is going up, so we are going to give a negative value there. And then the 2 we divide by 2, and then the time can never change the sign. It is always going to be positive 2.7 for the whole motion, and then we end up with a positive value of 19,6. And then what does that negative that positive means now? That positive means that this object, it is going to go downwards. So for 4 marks for the whole motion. So for the whole motion, we're having 3 options in which the learners can use. So basically the learners have a lot of options to can apply to this. Or else then we can start the motion from the maximum height. Now if we start from the maximum height, what does it tell us? It tells us that if you go to the graph, at the maximum height it is at this point here. Now there are quite a number of changes. From 0 to 2.7, it is for the whole motion. Hence, in the first option, we are using the time of 2.7. But immediately they are starting from this point here. It means now the time at which we are starting at time equaling to 0.7, and then we end up at 2.7. So our time change here, it is going to be final minus initial. So it is going to be 2.7, and then we minus 0.7. So it gives us the total time of 2 here. When we work with this, it is going to be equaling to a 2. Right, now let's look at option number 4. In option number 4, we are starting from the maximum height. Now, if we start from the maximum height, what does it tell you? We still use the formula V final equaling to V initial plus G delta T. Now, finally, when we want the final velocity. So initially what happens? Now, this object, initially, it should be at rest before it can go down. So hence, we are saying the initial velocity there, it is equaling to 0. Plus 9,8, and then we multiply by the 2, like I explained why it is a 2 there. So 1 mark for the formula, 1 mark for the initial velocity at 0, and 1 mark for the substitution in this. Now we end up with a positive 19,6. Now we interpret that negative 19,6. What does it mean? Now it means it is still going to be negative. It's going to be 19,6 meters per second, and then the positive means it is going to go downwards. Or if we take down as negative, what is it that we are saying? We are saying it is still the same formula, V final. It is going to be equal to V initial plus G delta T. Initially, it was at 0, 1 mark for the 0, plus now the G, it is going what? Downwards. Now, hence, it is going to be negative because we choose down as negative, and then the time, it is going to be positive. We end up with a negative 19,6. Now we interpret the negative, it is going to be 19,6 meters per second, and then it is going to go downwards. So that is option number 4. So the learner can choose any of these in any direction, but it's an option that they can use. And then option number 5, we are using the displacement. Now where do we start? We are also starting from the 0 position, right? Because we are starting from the maximum. Now what is it that it is changing here? Now from the graph we can see that from 0 position to the maximum, now the displacement, it is equaling to 19.6. So we are going to use the displacement of 19.6. Now let's look at how we approach it. Now it says there, then it is going to be down as negative. So we are having V final squared. It is equal to V squared initial plus 2G delta Y. 1 mark for the formula. And then initially the velocity there, it is at 0 plus 2G. It is now negative because it is going down. It is 9.8 meters per second squared. And then the displacement, the object, it is going down because it's starting from the maximum and then it is going down. So it is going to be minus 19.6 because we said anything going down should be negative there. And then the value, final velocity that we have, the square root that we are going to take, it is going to be a negative square root because it is going down. And then from there, the final velocity, then it is going to be 19.6 meters per second downwards. And from there, we go to the next one. Let's look at option number 6. In option number 6, what is it that we are having? Option number 6, we are saying therefore that we are still looking at the whole motion. Now we are using the delta y equaling to V final plus V initial all over 2 delta t. Now the change in position is starting from the top going down. So anything going down is negative. So that means it is going to be negative 19.6 and then V final plus 0 all over 2. And then we multiply by the time of 2 seconds, 1 mark for that one also. And then from there it gives us a value of negative V final, then it is negative 19.6. What does negative means? It means it is going to be 19.6 meters per second and then it is going to go downwards. Okay, and then from there we're having downwards as positive for the same formula, delta y equaling to V final plus V initial over 2 multiplied by delta t. And then what is it that we are having now? The displacement, it is now going down, but down we are taking it as positive. Now what does it tell you? Now V final still remains, we don't know. V initial, it is equal to 0 divided by 2, and then the time, it is still equal to 2. When we do this one, now we end up with a positive value of 19.6. What does that mean? Because we are saying down is positive, that means the 19.6 meters per second, then it is going to go downwards there. So that is starting from the maximum height. So option number 7. With option number 7, it is not very different from option number 1. But what we are saying now in that option is we are starting from the point of projection or where this object started to fall. Now, if we are looking at this is a parabola. And colleagues, it is important also to can use our maths information for our learners when we are dealing with vertical projectile. Now, at this point here, the velocity, it was positive here. But the same value of velocity, it is going to be here on the other side, but it is going to be negative at that point. So for our initial velocity in option number 1 and at option number 7, those velocities, they must be the same. So that is very important that we do have those. But the only difference is that they will be in opposite direction. So what I'm referring to, it is this. We'll see that option number 1 and number 7, they are actually the same because the only thing that is changing is the velocity here. You can see in option number 1, the velocity was positive, it was negative here. Now here it is going to be negative. And then for the whole of this motion, because it is downwards, that means we are taking down as positive. Now the value of the velocity there initially, it is going to be positive 8.6. And then the g, it is still going to be 9.8. But now the change here of time, where does it start? Now, if you look at the graph, we are starting from here, here, from this point. From this point, and the time at that point, it is 1.4. But the end time, it is 2.7. Now, what should we do about the change in time? It is going to be 2.7, and then we minus 1.4. Now, ultimately, we are going to get the time of 1.3 there. So for that, now, that's why here, the time that we are substituting here, it is equaling to 1.3 there. Okay. Now, ultimately, then we end up with a positive value of 19.6. Now, we interpret that value. Now, if we interpret that value, then it is going to give us the value of 19.6, and then it is downwards because we chose them down as being positive there. So that is one option. The other option is we are looking at down as positive. In fact, down as negative. Why? Now, what does it mean? It means your 8,6 is going to be negative, your G is negative, but your time, it is positive. Now, when we add all this, now it is giving us the value of 19,6. Now, that 19,6, it means it is going to be 19,6 meters per second, and then it is going to go downwards there. So I think it is okay with everybody. Now, 1 mark for the formula, 1 mark for the substitution, and then for the two substitutions in that equation, and then 1 mark there. So it is going to give a total of 4 marks. Or option number 8, where we are using the displacement now. If you are using the displacement, what does it tell you? It tells you that it is the same position. It is from the same position. So our displacement here, because it is from the same position as that one, then our displacement, then it is going to be 17.2. So we are going to use that displacement as 17.2. And then what is going to be our answer? Our answer or our option will be option number 8. We end up with that we are using the formula for V final equaling to V initial plus G delta T. Now we want V final. Okay, so that means now initially if we are looking at this, now it is going to be negative. So at that point, for it is going down. So as it goes down at that point, now the velocity, initial velocity, it is going to be minus 6,86, and then we square it plus 2, and then G, it is now negative, and then the displacement, it is going to be negative because it is all going down. So every value there, it is negative. And then ultimately we take the square root of a positive number, but that positive number then need to be taking the negative square root because it is going down, and then it is going to be 19,6 meters per second, and then it is going down. Or else for anything going up, what is it that is happening? We are still using the same formula. V squared final is equal to V squared initial plus 2G delta Y. Now, what is going to be the initial velocity? The initial velocity is 8,86, but it is going down. As it is going down now, it is going to be positive. Plus G, it is going to be positive. There is a 2 missing here. Just put a 2 there. And then plus 17,2. So ultimately, then we end up with the value of 3,84. And then that value, we take the negative square root of it, then it is going to be 19,6. And the final, it is going to be 19,6 meters per second, and then it is negative. Now, when it is negative, now we know that it is going to go. We are taking the positive value here because it is down. Here it should be positive, not negative like that. So it is going to be positive here. So we'll correct this memo here when we put it on the cloud space. So we'll put it finally as a positive there. Right, that is option number 8. Let's go to option number 9. With option number 9, we are using the formula that we used in option number 1. And then the only difference, as I indicated, it is on the displacement, in fact on the time, and then the signs, but everything it is the same. Now it is going to be delta Y equaling to V final plus V initial all over 2, and then we multiply by delta T. So it is going down, down is negative, so that means it is going to be the same height from where it is projected, so it is going to be minus 17.2, and then V final is what we want, and then finally initially it is going down, so it is going down at minus 8,6. We divide by 2, and then the time, the change, it is from 2,7 from 1,4 to 2,7. Now when you subtract it gives you 1.3, and then the value that we are going to get here, it is a negative value of 19,6. Now we interpret that value, and then it is going to be 19,6 meters per second. Now it is downward because of that negative sign there. Okay, or else if you are saying down, it is positive. Now what is it that we are going to have? It is delta Y equaling to V final plus V initial all over 2, and then delta Y. Now downwards it is positive. The change in displacement, it is going to be positive 17.2, and then the initial velocity, as it is moving from that point, then it is going to be positive. Now when you calculate all this, and then it is going to give us a positive 19.6, and then finally we are saying that the final answer, it is going to be 19.6 meters per second, and then it is going to go downwards. So for the 9 options, then we are having a total of 4. So the learners can use any equation of motion that doesn't contain I don't know which value it is not there, because we try to use everything we use, but it is calculating the final velocity there. So the only formula that cannot be applicable here, if we are calculating using only one formula, it is going to be the one that is saying delta y, it is equaling to v initial delta t plus half g delta t squared. That is the only formula that it is not applicable for this solution, but the rest, they are applicable, but we are not going to use all of those for multi-step to change this to multi-step. So what we are saying to you colleagues, it is encourage your learners to can try to avoid using multiple steps when they can use one formula to can get to the answer. So basically that is what we are saying at this point. Now let's go and check what is it that we are having for question number 4.5. For 4.5, it says there, sketch the velocity time graph for the motion of the brick from the moment it falls from the pallet until it hits the ground. Indicates all the time values and the corresponding velocities for 4 marks. Right. Now for this one, what is it that we know? Now, marking criteria, what is it that we have to look at? We are going to give a mark for the zero velocity at 0.7. So that means it is at the maximum height. We are going to give a value for that 1 mark. And then we are going to give a mark for the initial velocity of plus or minus, depending on how the learner used the direction there. So it can be plus or a minus 6.86. to indicate that at t equaling to 0, that means it is going to be the initial velocity there. And then the same magnitude of velocities, but different at time equaling to 0 and when time it is 1.4. So those values there, they must be the same. And then a straight line intersecting the axis at t equaling to 0.7. So for 4 marks. So that is what we are going to mark. Now, how will the graphs look like? Now, in this case, we are looking at downward as positive. Now, downward is positive. That means initially it was moving upward, so it should be a negative value here. So that value there must be indicated for 1 mark, and then the time at 0, and then this value here where we are having 1.7. Now, these two values, they must be equal, and then that value there, so the straight line there. So this is basically how the graph look like. So for this one, we just go and check on the criteria on how you are going to mark there. So the velocity at 0, 1 mark there, and any of these values 1 mark, and then that they must be equaling at equal times, and then the straight line. So basically this is how you are going to mark it, and then from there it is going to be 4 marks. Now in this particular case, it is up as negative, as positive. Now we start first with the 8.6, and then it is going down. Now it is intersecting the graph at 0.7. Now this value and this value, they are equal at 1.4, as you can see, and then it is a straight line. So basically this is how the 4 marks it was. So I hope it is not going to be a very difficult one to can mark. So basically that is how we are going to mark 4.5. Now let's go to 4.6, colleagues. In 4.6, it says there, when the brick lands on the ground, it is in contact with the ground for 0.3 seconds and then bounces vertically up with a speed of 4.59 meters per second. Okay, now it says there for 6 marks, calculate the distance between the pallet and the brick when the brick is at its maximum height after the first bounce. Assume that the speed at which the pallet moves upward has remained constant. So this is the part here. Now we have to look at 2 objects here. we have to look at the pallet, because as the brigade is falling, the pallet is still continuing to go up, as you can see here, that it is still continuing to move upwards, and so the brigade is going down and the pallet it is going up. So we have to calculate the difference in their distances. So the first bounce, the time it takes for the first bounce, it is going to be equaling to the time that the pallet will be still going up. So we still have to calculate at that height when it is reaching the maximum height, and when the pallet, when this brick is reaching the maximum height, at what height will be there the pallet, and then we take this the difference between the two to can get to this solution. So this is how we are going, how we have approached it, and then I think it is going to go and make sense. Now, what is it that we are going to do? Now we are going to mark it positively from 4.1. Now, in 4.1, what is it that was calculated? In 4.4.1, remember we are calculating the speed at which the pallet was lifted, or the pile was lifted. So that means it is the initial velocity. So we are going to look at that one. So we are going to use that value, and then the value that the learners got in 4.4.1, then we have to use it here. Now, to calculate the time for the brick to reach the maximum height after the first bounce, what did we do? Yeah. We are looking at this, that, okay, for option number 1, up as positive, we are going to have the formula, because we calculate the time, because we have everything except the time. So we are saying that we are looking at the brick to reach the maximum height. Now, it means we have to calculate that time, because we know the initial velocity and then we know the final velocity. Now we can calculate the time. So it is going to be V final, it is equaling to V initial plus A or G delta T. No mark on that formula. The mark, it is on the substitution. So what is it that we are substituting? V final, then it is going to be equaling to 0. And then the brick, it was moving at 4,5, it is bouncing up. And then G, it is equaling to minus 9,8. 1 mark for the whole of that substitution to can calculate the time. So that is the time that it is going to take as it bounces off. So in other words, we are here. Now there was a contact time here, and then this brick bounces off and reaches the maximum height. So what we have calculated, we use this velocity in which it started with of the brick, it was 4,59, and then when reaching this value here, it is equaling to 0. So that is the part that we have calculated here. So we have calculated the time here, which time it is at that point. Now, from there, what is it now we are saying? We are saying now, the time taken here, it means it is going to be equaling to which times now here? It is going to be equaling to this time here of 2,7 plus the time in which it was in contact, which was the 0,3, because it was in contact at this point, and by a time of 0,3, plus the time that we have just calculated, which is going to be equaling to 0,468. That is the time that we have been we used here. So hence here at this point we are saying that this is the time that the times that we are using, and then it gives us the total time of 3,468 seconds. So that is the time for the whole motion of the crane. So going up, that is that time. Now from this time, what is it that we have to use now? Now we have to calculate the time the pallet it is used in going up. So which one are we having now? Now, because we want the distance now, importantly, it is going to be your delta y. It is going to be equaling to V initial plus A delta T squared. Now, initially, as we have seen in 4.4.1, that the initial velocity is equaling to 6,86. And then we multiply by the time. Which time it is this? It is for the whole motion of the pallet, so it is that time that we have taken here. So we put it in there, 1 mark for the whole of that substitution. Now, coming to the acceleration of the crane, remember it is said that the crane, it is moving at a constant velocity. Now, because it is moving at a constant velocity, the velocity is not changing per unit time or per time. So because it is not changing, that means then give us the acceleration of 0. So it makes the whole of this part A delta T squared to be equal to 0. So we end up with only the distance of 23,79 meters. So what does it mean? It means this pallet now, it is at a distance of 23.79. So 1 mark for this height here, and then 1 mark for the calculation of that distance here. So we are already having only 3 marks up to that point. It is 1 mark for the substitution there, 1 mark for this calculation of the distance, and then interpreting that distance to be the height, 1 mark there. Right. Now, what is happening here? This, remember, it is the distance that the pallet has moved after the brick has fallen. Now, above the ground, where it is this. Now, above the ground, it means this, it is at this distance that was calculated, but remember the brick falls from 17.2. So we have to add that 17.2 to go to the distance of 40.99. So that is where the pallet is now. Now let's go for the brick now. Where is the brick at this point? Now for the brick, what is it that we know? At the maximum height, we know that the velocity is equal to 0. So we are taking up as positive. Now initial velocity we do have, it is given to us. And then 2g delta y squared, it's fine. Now we want that delta y. So finally we know at the maximum height after the bounce it is equal to 0. The initial velocity is equal to 4.59, and then we square it. And then 2g it is going down. So it is negative, and then we end up with a distance of 1.075 meters. Okay? Or if we are taking down as negative, then what is it that we are having? V final is still equal to 0. Now the initial velocity is going to be negative because it is going to be going what? Upwards. Okay? And then your g is going to be positive. Now the value is going to be equal to negative 0.75, but now we have to interpret it that. Now the height above the ground, where it is this, above the ground, now it is at the height of 1.075. So 1 mark, it is on the interpretation of the distance calculated there. So it is on 1.075. So that is the 4th mark that we are having for this calculation. Now calculating the distance, what is it that we are having? Now the distance for the hole then means it is going to be that distance that the pallet is, and then we subtract it from where this maximum height is. Remember this 40.99 is from the ground. So the pallet, the brick, it is a distance, certain distance above. Now that is why we are subtracting these two, and then we are getting the answer of 0, in fact, of 39.915. 1 mark for the final mark, final answer. 1 mark for the height of the brick, 1 mark for the substitution in getting the height, and that means for this you are having 2 marks on the substitution in calculating the bricks, the interpretation, and then subtraction, and then the answer, it is also 1 mark. For the brick, for the pallet part, we are having 3 marks. So from there we are okay. We are having 6 marks. I hope it does make sense, and I think we can use this, especially to interpret that why this acceleration there, it is equal to 0. Because it is in free fall, but we are having another part. The crane, it is using another force to move up, which is in the tension, maybe in the string. So as it is going up, then it is the force that it is. So it is not in free fall, even though it is under a vertical projectile motion. So we have to make our learners aware of such. And then from there, we go to question number 4.7. Now for 4.7 there, it says there, calculate the impulse of the brick during the bounce. Take the mass of the brick as 1.9 kilograms. As 1.9 kilograms. Now for that one, what is it that we are having? We are having positive marking from 4.4.2. Now in 4.4.2, remember what we calculated? We are calculating the velocity with which it hits the ground. Now we are looking at the brick as it hits the ground. So we have calculated from 4.4.2 the velocity with which it hits the ground here. We are having the contact time here, and then the velocity in which we are having as it goes up. So meaning that this is going to be our V initial, and then this is going to be our final, and then this is going to be the contact time that we are having. Now what is it that we are doing here? It means it is impulse. Now what is it that we know about impulse? We are taking down as positive. And then we have calculated this velocity here, which is happened to be the initial velocity. And then the one with which it is moving up the ground, now it is going to be our final velocity. K as the impulse it was occurring. Now, what is it that is happening? We are saying down it is going to be positive. Now, what is it that we are having? Impulse it is equal into F net multiplied by delta T. So we did not get the force. So what is it that, because we don't have the force, then we have to go for the impulse momentum theorem. That's what we are going to use. Now the mass it is 1.9, it is given. Now this object it is going up with a velocity of 4.9, but now we are saying down be negative, so that makes this velocity to be negative. And then minus, what happens to the 19.6? The 19.6, then it is the velocity with which it is going to go up. Okay, remember the velocity with which it is going down with, but it is up for the for that particular value. So ultimately we end up with the velocity of 49.96 meters per second, and then it is going to be 45.96, and then the unit there it is newtons second, because it's an impulse here. Force it is in newtons, and then time it is in seconds, and then importantly the mark it is on the direction. It's very important there. So it is 1 mark for the formula, 1 mark for the whole of that substitution, 1 mark for the final answer, and then 1 mark for the direction given there. Option number 2. In option number 2, it is the same formula, and then what we do is the mass is still 1.9, then the final velocity, it is the one of 4.9, the one in which it is going up with. So up it is positive, and then it was hitting the ground, remember, initially at 19.6, and then it is negative because it is going down. So from there, what it is that is going, then we end up with a positive value of 45.96, and then we interpret it that it is going to be 45.96 newton second, and then it is going to go upwards. So this is how we come to the end of the physics part, and I hope that we will enjoy this paper, and then the marking, I hope it is clear, and then everybody will be able to can mark. Now we are going to take about 10 minutes break, and then thereafter I'll try to address some of their concerns and some of the questions that we have put in, even some other options. We are going to have a look at them before you can say this is correct or whatever, whatever it is an input that we have put in, and then from there I'm going to hand over to Memo to take over for paper 2. Thank you very much, colleagues. Let's take a break.
Good morning, colleagues. I hope you're fine. I've seen that paper 1 went well, and I hope also the marking is going to go well. I want to talk about this because, colleagues, let us ensure that at this time of the year, we become strict in terms of marking so that learners are able to rectify their mistakes now and they won't repeat them again later. Remember the March test, even though it's part of the SBA, but the percentage is still a bit less than the other formal tasks that are coming. So let us be strict now and ensure that they rectify their mistakes so that in the other tasks that will carry a bigger weight, they don't repeat the same mistakes. And more especially at the end of the year. Now, colleagues, Mr. Nzia will put in the other options if they are there. We are going to put them in the blog, and we are also going to, every subject advisor is going to give it to you in your WhatsApp group. Now, let us continue with 1.8. In 1.8, the question was, study the following pairs of organic structures, and they are given there as 3 pairs. And then, which one of the above are structural isomers? Now, the correct answer there for us is D. All of them are structural isomers. So 1.8 is D. I don't think that will be a problem because I want to believe our learners know what a structural isomer is. And also, colleagues, let us try to make sure that they know, even though they know the definition, they are able to apply the definition to get the correct answers. Now, last year, this question, a similar question was 1.8, and the average of the scripts that were analyzed there was about 18%. The question is, what is the empirical formula of ethyl ethanoate? And colleagues, this was in the diagnostic report. It is there in our free state internal moderators report that each teacher of the free state got at the beginning of the year. And we also asked you, colleagues, to go through the internal moderators report as well as the diagnostic report when it comes out so that you rectify the mistakes before the learners write their formal tasks. So I hope you did that, colleagues, but even if you didn't, so ensure that now you are going to do that. Now, in the internal moderators report, it is clearly written there that the learners confused the empirical formula with the molecular formula. So learners know what the molecular formula, for example, in this case of ethyl ethanoate is, but now they do not know the empirical formula. Remember, the empirical formula is the simplest ratio of these atoms of that molecule. So they should know that ethyl ethanoate is something like that. And remember, all the hydrogens must be there, meaning this is the structural formula of ethyl ethanoate, meaning there are 4 carbon atoms, and then there are 1, 2, 3, 4, 5, 6, 7, 8 hydrogen atoms, and there are 2 oxygen atoms. And this is the molecular formula of this ethyl ethanoate. But the question did not ask about the molecular formula. The question asked about the empirical formula, which is the simplest ratio. So in other words, you'll divide by the smallest ratio that is possible. So we can see that there are 2 oxygen atoms. So if you divide by 2 in each one of them, therefore you will get C4, C2, H4O. So C is the empirical formula and A is the molecular formula. The question did not ask about the molecular formula, but the question asked about the empirical formula. So the correct answer there for 1.9 is C. And all colleagues, just ensure that you address that with your learners. Remember, empirical formula, they do in grade 11, but in the examination guideline, it is all the topics of grade 11 that we need in grade 12 are clearly stated there. And one of them is the empirical formula. And then question 1.10, the structural formula of an organic compound is shown below. And then also in the internal moderators report of last year's paper, it is clearly written there for question 2.2.1 that remember this is a haloalkane. So if it is a haloalkane, when we name a haloalkane, we use the rules of alkanes. So that case in the internal moderators report, it is written there that learners treat the functional group as if now when we start counting the number of carbon atoms, it takes preference. Remember, this is a haloalkane. So the rules that applies there are the rules of alkanes. It is just an alkane with a halogen. So in other words, you are still going to count the longest carbon chain, and then we are still going to start counting the number of carbon atoms from the side closest to the branch. So if you count the longest carbon chain, our fluorine, our ethyl, and these methyls will become now the branches, because we are going to have 5 carbon atoms in the longest carbon chain. So if now these become branches, now you can see that when you start from the left, the branches are on carbon 2, carbon 3, and carbon 4. But when you start counting from the right to left, the branches will still be on carbon 2, carbon 3, and carbon 4. Now, the next types of rules come in now. So since they are on the same carbon atoms, whether you start from left or right, now you check which side the branches are closest to, or which side will give us the branches with the lowest number in terms of where they are positioned. So when you start counting from right to left, you can see that the branch will be on carbon 2, which is the fluoride, and the branch will be on carbon 3, which is the ethyl, and another branch will be on carbon 4, and there are 2 branches there, which are the methyls. But in other words, when you start from left to right. But when you start from right to left, the branches, both of them will be on carbon 2. And then the next branch, which is the ethyl, will be on carbon 3. The last branch, which is the fluoro, will be on carbon 4. So the lowest number there will be when you start from right to left. Therefore, it means the correct one is from right to left, or the ones with more branches will be closest when you start from right to left. Therefore, it means this will be our carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. Therefore, the correct, and then we go now alphabetically. Ethyl comes first, then it's fluoro, and then it's methyls. So our correct answer there will be B, which will give us 3 ethyl, 4 fluoro, 2,2 dimethyl pentane. Also that one, colleagues, please ensure that you address with your learners. And then, now that is all for chemistry in the multiple choice questions. Now let's go to question 5. The letters A to C in the table below represents 3 organic compounds, and they are given there. Use the information in the table to answer the questions that follow. Compound A is a tertiary alcohol. 5.1.1, define the term tertiary alcohol. Now, in the internal moderators report, again, for question 2.3.1, it's shown that even though it was not a tertiary alcohol, it was a secondary alcohol, but it's shown that learners had a difficulty in defining a tertiary alcohol. For example, in using the terms that are incorrect. For example, instead of saying hydroxyl, they were saying hydroxide. Remember, this is incorrect because we are not even no longer talking about organic chemistry. So it is a hydroxyl group, which is the OH group. And then some learners were talking about the functional group. That does not have a problem. But let us ensure that they understand what the functional group is. For example, remember in alcohols, we take this as a functional group, but it is also acceptable just to take the OH as the functional group. So they need to understand when we talk about the functional group, which part now are we talking about in the definition itself. So colleagues, let us ensure that they understand. So I decided to only give one option in the memorandum, which I want to believe is understandable to all of them. The carbon atom bonded to the hydroxyl group, which is that OH group, colleagues, is bonded to 3 other carbon atoms. So now, if this learner just say the carbon atoms bonded to the functional group is bonded to 3 other carbon atoms, is this learner taking this as a functional group? And then saying this carbon that is bonded to this functional group is bonded to 3 other carbon atoms, which is correct? Or is this learner now talking about this OH, which is the functional group, and saying that now the carbon, in other words, the learner would say now the carbon that is bonded to the OH, which is the functional group, is bonded to 3 other carbon atoms. So this would be correct. But if the learner says take this as a functional group, the whole of this, let me encircle it, the whole of this as a functional group, then the learner can say now this carbon that is bonded to the functional group is bonded to 3 other carbon atoms, which will now be incorrect because now this will make it a primary alcohol. So let us ensure that our learners know what the functional group is. So if, because when we teach, we might show them both the functional group, the OH and the OH with a carbon atom as functional group, instead of just saying the carbon where the functional group is bonded, which might be confusing to the learners, let us rather say the carbon where the hydroxyl group is bonded to 3 other carbon atoms. So that is 2 marks. Now, colleagues, this is just a definition, but it is important to ask these definitions in terms of questions now, the application of these definitions. Now, in the next question, the question says, write down the following for compound A, the name of its functional group. So the name of the functional group of an alcohol is a hydroxyl group. And colleagues, if this learner says it is a hydroxide group, please do not correct the learner, just write hydroxyl and give a mark. Hydroxide is incorrect. It's 0 out of 1. Not almost correct. It's incorrect, completely incorrect. So let us not give that mark. And then question 5.1.3, we are now applying the definition. Write down the IUPAC name of that tertiary alcohol. So if the learner understands that A is a tertiary alcohol, and now we want the IUPAC name of that tertiary alcohol, therefore the learner will be able to say, okay, I said that the carbon with a, let's say, with a hydroxyl group is bonded to 3 other carbon atoms. Therefore, I will have 4 carbon atoms here. But the molecular formula has 5 carbon atoms. Therefore, it means I can put the 5th carbon atom anywhere here. It will still give me the same IUPAC name. Therefore, in this case now, we remember that we start counting the carbons from the side that is closest to the functional group. So the functional group is closest from the left, because when you start counting from the left to right, it will be on carbon 3. But when you start counting from right to left, it will be on carbon 2. Therefore, the closest is when we count from right to left. Therefore, we are going to now to have a methyl on carbon 2 and a hydroxyl group on carbon 2. So the correct answer there for us will be, it will be 2-methyl butan 2-ol, or 2-methyl 2-butanol. Now, because it's 3 mark, what is the criteria? For butanol, it's 1 mark. And then for identifying a substituent, so when there's a methyl, it's 1 mark. And then for the 3rd mark, everything must be correct with the correct number of, the correct numbering. In other words, it must be 2-methyl and it must be butan 2-ol, correct numbering. And then with the correct sequence, with the correct hyphens. If there's an additional hyphen, you penalize. If there's a missing hyphen, you penalize. That's how we marked last year. Also, the additional hyphens, we penalized. And then if the learner doesn't use a comma in between, or in this case, there's no comma anyway, so there won't be a problem. But any mistake, the learner will lose the 3rd mark. And then, colleagues, I had initially put 3-methyl butan 2-ol as another option. But when I had a look early this morning, I decided that you need to remove it. Reason being, 3-methyl butan 2-ol will not be a tertiary alcohol. So please cancel that 3-methyl butan 2-ol. It is incorrect. The only correct option is 2-methyl butan 2-ol. Now, say for instance, we have a learner. Learner A writes 3-methyl pent 1-ine. Remember, is it this one, 5.3.2? Okay, let me leave that one for now. I'm going to have that one for the next question. And then 5.1.4. The question in 5.1.4 is write down, for the same compound A, write down the structural formula of its chain isomer. Remember, for the chain isomer, they must have different chains. So in this case, the chain carries 3 carbon atoms. Now let us check a chain isomer of the 2-methyl butan 2-ol. It must have the same molecular formula, but different chain. So in this case, we moved from a chain with 4 carbon atoms to a chain with 5 carbon atoms. Remember, sometimes learners are used with having a longer chain to moving to a shorter chain. So let us ensure that they also know that it can be longer than the one that is given to them. So in this case, their chain isomer is this one. Now, it will be 1 mark for the functional group, and then 1 mark for the whole structure correct. In other words, if, for example, the learner has any alcohol, whether the OH is on carbon 2, carbon 3, or carbon 4, as long as it's an alcohol with correct number of bonds, remember, the bonds must be included. There must be 3-4 bonds around the carbon, and then there must be an OH there. If it is an alcohol, the learner will get 1 mark for the functional group, but if the other part of the structure is incorrect, then the learner will get 1 out of 2. And if they are missing hydrogens, like the ones that I've drawn, it is 1 out of 2. And then question 5.2, write down the following for compound B. A structural formula of its functional group. Now, the structural formula of the functional group of compound B is only this one, colleagues. For example, if the learner just writes 6C double bond O like that, with no carbon atoms on the left or on the right-hand side. That is incorrect. Therefore, the learner will get 0 out of 2. Or if the learner writes C double bond O with the carbons on the sides, but these carbons do not have bonds on the other side, that also is incorrect. The bonds must be available for 1 mark. And then 5.2.2, for the same compound B, write down the IUPAC name of its straight chain isomer. The IUPAC name of its straight chain isomer is butanol. Now, also for that one, colleagues, last year in the internal moderators report, for question 2.1.2 and another question in question 4, learners were writing the number next to the al there, showing that a functional group of an aldehyde is on carbon 1. For example, if the learner writes butan 1 al, remember it's 2 marks here, colleagues. It's 1 mark for the but, and then it would have been 1 mark if everything else is correct. But because of the 1, remember, for the aldehydes, we don't show the functional group because the functional group of an aldehyde will always be on carbon 1. Therefore, because of that one, you'll penalize 1 mark. So the learner will only get 1 out of 2. And please, colleagues, let us ensure that we do that. So it's 1 mark for the stem, which is but, and then if everything else is correct, it's butanol, the learner will get 2 marks. And then 5.3, write down the following for compound C. The general formula. Also in the internal moderators report, there was a warning there that learners confused the general formula, the structural formula, as well as the molecular formula. So let us ensure that the learners know the differences. Now, the general formula of compound C there is CnH2n minus 2, since it is an alkyne. So CnH2n minus 2. That's the only correct general formula there. 5.3.2, write down the IUPAC name of compound C. So the IUPAC name of compound C there is 3-methyl-pent-1-ine or 3-methyl-1-pentyne with the correct hyphens there. So since it is 3 marks for pentyne, it's 1 mark. Excuse me, for identifying the substituent, which is methyl, it's 1 mark. And then everything else correct is the third mark. And for the third mark, for you to give the third mark, everything must be correct, including the numbering, the sequence, and the hyphens. Now let us go back to the one that I wanted to show you earlier. Here's a learner. He writes 3-methyl-pent-1-ine. We said for the first mark, the learner must have this pentyne, it's 1 mark, and then must have a methyl, it's the second mark, and then the numbering must be correct. Since it must be 2-methyl, it still must be 3-methyl, but the learner in this case has an additional hyphen there in between the name. Because of that additional hyphen, colleagues, let us penalize, because last year learners lost a mark for that one. So let us penalize now so that they don't repeat the same mistake. As long as it's within the name, there's no number there, we don't include a hyphen. So let us ensure that they know that. And then in this case, this pentyne is methyl. Everything else is correct, but the numbering is incorrect. Therefore, the learner also will get 2 out of 3. This one, the methyl is correct, the pentyne is correct, the numbering is correct, but unfortunately, there's a missing hyphen. So this also will get 2 out of 3. So let us check all those bullets, colleagues, when we mark. Now, let us quickly go to question 6. In question 6 there, the boiling points of 5 organic compounds P, Q, R, S, and T are studied. and then define the term boiling point. Last year, 3.1, we said the learners had a problem with boiling point. Instead of writing, most of them, they were saying boiling point is a point. It's not a point, but it's a temperature at which the vapor pressure equals the atmospheric pressure. So once they say it's a point, there is no mark. So we check the underlying weights. In this case, there's temperature, and then there's vapor pressure equals atmospheric pressure. If we mark this according to the criteria that is given. If one or more of the underlined phases in the correct context is missing, you deduct a 1 mark. So if the learner says it is the point at which the vapor pressure equals atmospheric pressure. So vapor pressure equals atmospheric pressure is a correct context, but it must be a temperature. So that learner will get 1 out of 2. And then some of the learners will say vapor pressure is in equilibrium with the atmospheric pressure. That is incorrect, colleagues. So let us ensure we mark correctly. And then 6.2, the boiling points of P, Q, and R are compared. Besides the conditions used to determine the boiling points, give a reason why this is a fair comparison. Now, when we have questions where learners either are supposed to identify the variables or say whether the question is fair or not, some of the learners lose a mark. Remember, those types of skills we start with assessing from grade 10. So every time when you have a practical based kind of a question, ensure that you assess those variables, writing the investigative question, the hypothesis, the conclusion, because remember, in also the hypothesis and the conclusions, all that, they use the independent and the dependent variable, the relationships between those. So if they can't identify the variables, it becomes a problem. Or if they don't know when the question is fair, they would not know. So colleagues, let us ensure that also in the practicals, when we set our own practicals, we include questions like this. Now they must know that for a question to be fair, it means there must be only one independent variable. And in the structures given already, they are shown that P, Q, and R are all aldehydes. But the difference between them, already they are shown the independent variable. It is the chain length. Now they must show that it is the only independent variable that is there. Otherwise, they must identify the controlled variables. So in this case, we now want the learners to say, as they are given from the table, they have the same molecular mass, meaning there's only one independent variable. Molecular mass is the same. Or they have the same molecular size. But now, if they say they have the same carbon atoms, number of carbon atoms, they must still show us that they are from the same homologous series. Because we can have the same number of carbon atoms, but different homologous series. In other words, in that case now, the independent variables will now vary. So it must still be the same homologous series. So for the learner saying the same number of carbon atoms must also say same homologous series. So same number of carbon atoms only is no mark. Same homologous series only is no mark. For both of them, it's 1 mark. And then question 6.2. In question 6.2, the boiling points increased from compound P to compound R. Fully explain this trend for 3 marks. By now, I think learners should know that when they explain the trends, they must talk about the structure, the intermolecular forces, and the energy. Now, because the question already says from P to R, so in the learner's explanation, if the learner does not say from P to R, you should take that the learner is explaining according to this option on page 10. Because already the question says from P to R. So in other words, if the learner does not say from P to R, you'll check whether the learner is saying more branched, it's 1 mark. Or it has the chain becomes shorter. Or it becomes more compact, more spherical, or the surface area decreases or becomes smaller. It's 1 mark. And therefore, the strength of intermolecular forces decreases, or the intermolecular forces becomes less or weaker, or the van der Waals forces becomes less or weaker, or the London forces, dispersing forces, induced dipole forces, induced dipole forces, they become weaker. That's the second mark. And then the less energy will be needed to overcome or to break the intermolecular forces. Now, last year, in question 3.4.2 and in question 3.3, in the internal moderators report, it is clear that the learner, some of the learners were saying more energy is needed to break the bonds. Some of them said between carbon atoms. So once the learner says bonds, colleagues, we penalize. Remember, there's a difference between bonds. For example, in this case, say for instance, you are talking about pentanal. This is pentanal molecule. This another pentanal molecule. In between these molecules, we have intermolecular forces. So this is what we are talking about for the phase to change. We are talking about intermolecular forces, the forces between the two molecules. So these are intermolecular forces. But if they say bonds, it means here we are talking about pentanal. In this case, this learner is now talking about between this carbon and that carbon, there's an intermolecular force. Or between this carbon and oxygen, or somewhere there, within the same pentanal molecule, there's an intermolecular force. Here, we'll have bonds. So when the learner says bonds, he's talking about this. And we're not overcoming the bonds, but we are overcoming the intermolecular forces. And please explain that to the learners, colleagues, because when we talk about the intermolecular forces, we are not talking about one molecule, but we are talking about two molecules, the forces between them. So once the learner says less energy needed to overcome the bonds, even if it does not say bonds between carbon atoms, when the learner says bonds, then the learner must forfeit this mark. The learner must say between molecules at least, then you can give the mark. But discourage the use of bonds. Now, instead of explaining from R to P, the learner can also explain from P to R. So if the learner explains from P to R as given in the question, then the learner must say the chain length becomes longer, or it becomes less branched, or it becomes less spherical. The intermolecular forces become stronger, or more intermolecular forces are there, and then more energy will be needed to overcome the intermolecular forces. So in this option, because P to R is already given in the question, in this option the learner does not need to say from P to R. If the learner does not specify whether it's explaining from P to R or R to P, if it's not specified in the question, you mark according to the option in question 9. For you to mark according to the option in question 10, the learner must definitely say from R to P. Now, let us go to the last question, which is question 6.3. The boiling points of compounds R, S, and T are given below, not necessarily in the correct order. Which one of the three boiling points is most likely to be the boiling point of compound S? And when we look at the compound S, it is an alcohol. It's a primary alcohol. So since it is an alcohol, then the learner must compare that alcohol to, remember it says R, S, and T. Therefore, must compare the alcohol to an aldehyde as well as to the carboxylic acid. Therefore, the learner would be able to say that the boiling point of an alcohol, which is S, is 138 degrees Celsius. But because degrees Celsius is already given in the option, the learner can just say 138 is fine without putting the unit. But always emphasize the unit, colleagues, when you teach. So 1 mark for 138, and then for the explanation, explain the answer, it's 3 marks. Now, in their explanation, colleagues, let us check the criteria. The first mark for the criteria, the learner must compare the strength of all 3 of them. That's the second mark. And then for the third mark, the learner must compare the boiling point of R and S. And then for the fourth mark, the learner must compare the boiling point of S and T. So it's 1 mark for 138, and then 1 mark for comparing the strength of intermolecular forces for all 3 of them. And then the third mark, comparing the boiling points for R and S only. The fourth mark, comparing the boiling points for S and T only. Or, instead of using the boiling points, it's 1 mark for 138, 1 mark for comparing the strength of the intermolecular forces, and then the learner can compare the energy needed to overcome intermolecular forces of R and S for the third mark, and then the energy needed to compare, to overcome the intermolecular forces of S and T. That's the fourth mark. So hence, in your options there, colleagues, I want you to remove the last bullet after the or, so that you can see that the mark for the bullet, the last bullet, it's either for the intermolecular forces, it's either for the boiling points or for the energy needed to overcome the intermolecular forces. So it's 1 mark for 138, and then the third mark, the learner can say, alcohols have intermolecular forces which are stronger than those of aldehydes, but weaker than those of carboxylic acid. All those 3 comparison of boiling points is 1 mark. And then for the third mark, alcohols have higher boiling points than aldehydes, 1 mark, but alcohols have lower boiling points than carboxylic acid, that's the fourth mark. If not comparing the boiling points, it's 1 mark for 138, and then 1 mark for saying alcohols have stronger intermolecular forces than aldehydes, but weaker intermolecular forces than carboxylic acids. That's the second mark. Then the third mark, therefore alcohols require more energy to overcome intermolecular forces than aldehydes, 1 mark, but they require less energy to overcome intermolecular forces than carboxylic acids. That's the fourth mark. So colleagues, I hope everything is clear in terms of marking. And colleagues, it is important that when you mark, you transfer your marks to the right-hand side. Remember, we are still going to give you the links for you to fill in the error analysis. So when you mark, for example, question 2.2 and you get 2 marks, it is important to give 2 marks there on the right hand side, and then 2.3 you get 1 mark, you transfer the mark on the right, and then maybe 2.7 it's no mark, you transfer to 0. And for question 2 there, you'll add this, and then at the top you'll write 3 there. Why is it important to do that? Because in the error analysis, we don't need the total mark, for example, for question 2, but you'll need a mark for question 2.2. So if you've already given a mark there, you won't go back now and count the ticks for the error analysis and say it's 2, and count the tick for 2.3 and say it's 1. Already you have written the marks there. So when you write, you give the error analysis, you'll just take those marks and put it in the error analysis. Colleagues, the reason why every year you are given the diagnostic report and the internal moderators report is for you, when you teach a topic and you assess that topic, when you're still teaching the topic, you tell the learners, these were the mistakes that the previous year's learners were making. So you will be penalized if you do this. So ensure that when you answer your question, you don't do that, because every time when you do this, you will be penalized. And in the tests that you are giving them, because you have already told them that they will be penalize them so that they know how that is done. You don't say one thing and then you don't do it in the test. Whatever you say in class that they will be penalized, in the test, do penalize so that they know. And let us not be too lenient now, because this test does not count much in the final SBA, and we want them to rectify those mistakes. So thank you very much, colleagues, for everything. All of the best with your marking, and please do submit also the curriculum coverage. Thank you so much, colleagues. Have a great